Welcome to the recording regarding domain modeling in the course 1dv607, Object-Oriented Analysis and Design using UML. A domain model is a visual guide over a specific problem in a specific area. The domain model contains the important concepts, the relations between these concepts, and constraints on these relations. So the idea is to facilitate understanding of the problem. That is, the domain model is an analysis artifact, something we do to understand what the problem is, and not how to solve the problem using software. The main idea is that we should be able to communicate and understand this problem area better. And one of the key benefits of domain modeling is that you can get this understanding together with end users and domain experts, the experts of this problem area that you are supposed to develop a software for. So first we need to understand things, and that we can do with the domain model. In short, it kind of like puts all of the requirements in a context, all of the requirements within this problem area. We use the domain model to find problems and find opportunities for improvements in the requirements. Maybe we can find some new and exciting features that can be developed by using the information that is shown in the domain model. So we can improve on the requirements, and we can find problems in the requirements. For example, in the dice game, we found that we had not really specified the number of dices that we wanted to use in the game. And this is typical for domain modeling, that we find these constraints and relations that we maybe miss by just writing text. To visualize and communicate the domain model, we use a simple form of UML class diagram. We will have classes, we will have associations between the classes. The associations will have names, and they will have these multiplicities. So let's take a look at a quick example of a domain model. We will use GenMyModel for this example. There are plenty of tools out there, and the notation is really simple, so you should be able to do this in almost anything. For this example, I will be talking a little bit about a simple administrative system for student and course registrations. It's something you should be fairly familiar with, and that's an advantage, of course, when we talk about things, because you are familiar with the domain. Essentially, you are a little bit of end users or domain experts in this area yourselves. But you can imagine doing this as a software engineer in an area that you are not really familiar with. It becomes really a learning experience, creating the model itself. So I will just rename this. And two of the most important concepts within this domain is, of course, the student and a course. And let's say I'm a teacher in this course, and I would like to have a list of all the students who have attended this course. Then I would need to have a relationship between these two concepts, student and course. And in domain modeling, we use the association. Now we get a lot of information here in YUML, but we will remove a lot of this information because we really don't need it here. And I think by setting a space, we can remove the text. And let's give it a name. and we show the association name in this case. So we typically don't use the role names for domain modeling. We use the association names instead. So let's talk about the multiplicities. So one student can attend 0 to 1 course right now. That's probably not what we want. We want a student to be able to attend many courses. So we will change this multiplicity to many. And vice versa, a course can be attended by many students. So we will set down that one to many too. So basically this is the starting point maybe of this domain model. And it supports the requirement of a teacher wanting to know that what students do we have for a particular course. And let's just add an attribute here also so that we can, so let's say, let's add a code. Know about the course codes, right? And we can have it as an undefined so long. And maybe we have an attribute here, and it's first name, and that will most likely be a string. So we can add some data to these conceptual classes. We can add relationships, associations between the conceptual classes so that we can know that a student has attended a course. One interesting thing is that we can test drive our models using an object diagram. So let's try to create that. So in a object diagram we show objects, and let's just say that we have 2 courses. So it's a course, and the course code is 1dv607. Well, good. Awesome. So the object name is awesome and the class name is course. Let's add another course. Not so great. And it will be a course like that, and let's add the one dv 1 2 3 fdv like that. So now we have 2 courses, and let's add some students also. So this will be a student, and we will just call it 1. And with this will be a student, we will call it 2. And this will also be a student 3. We could add the names here also, of course. And now that we have student objects and we have the course objects, and we can just imagine that we have a link between the first student and the awesome course and the not so great course, and the second student also attends the awesome course, and third student attends the not so great course. So this is basically how the objects can be connected, giving our class diagram. And this supports the requirement that I can know this awesome course object 1dv with the code 1dv607, and I can know the students that are attending, the first student and the second student. I can know the course that's not so great, and I can know that the first student and the third student attends it. So if this is my requirement, that you should be able to know what student has attended what courses, this model should suffice. And in the case that you have several links, you can use the name for that link. So if you have several associations between the same objects in the class diagram, then it can be beneficial to add the association names also in the object diagram, in an object diagram. This is basically for test running the class diagram, so we know that we have captured the information needed to support the requirement. One of the major points in domain modeling is that the domain model and the requirements, they coexist. They are not meant to replace each other, so the domain model is not meant to be a copy of the requirements. Rather, the requirements are things that describe how the system should behave, the rules, and who is doing what in this system. Typically, requirements are quite dynamic and shows activity, shows what the system should do in certain situations, what steps a user must take to perform something. The domain model, as it's a class diagram, it's static in nature, so it does not really show time. It rather shows the information that is needed and the relationships between these blocks of information, these conceptual classes, to support the requirements so that we can do the things that we need to do in the requirements. We saw this maybe in the small example that we needed to know what students had attended what courses because we had this idea that we wanted someone to be able to know that for a particular course, these particular students had attended the course. This is something that is important, that the requirements and the domain model, they coexist. The requirements delimit the domain model, and the domain model finds problems and opportunities in the requirements, so it refines the requirements and makes them better. So the basic way you develop a domain model is to try to think like a map maker. So map makers typically do not invent new things when they create a map. They try to do a map over the real world, how the reality actually works. So they model the real world. Also, they use existing words. They don't invent new names for things. They use the names that are common in this area that they are trying to map. Also, they need to find a good level of abstraction. So if you are doing a map over the entire world, you cannot really put too much information in your map because you couldn't be able to see anything. So this is also important, that try to find a good level, and typically you find this level by using the requirements, and it's important that you complement the requirements and do not try to replace the requirements. A map maker does not add things that does not exist. So typical problems we have when doing domain models is that we are thinking like software developers and we add things that are software specific, so a database or something else that is purely a software mechanism or a software concept. We also have a problem that a fairly large system can span over several different domains, and maybe you need to understand all of these problem areas. Typically then you do several domain models, so you try to not mix domain models into one large model. It's better to do several small models that cover a specific area. And finally, a mapmaker uses the experts that are available. So use the end users, use domain experts, people that really know this problem area, that work in this problem area. You can of course also use other sources such as books to learn about this problem area that you are trying to develop a software from. Or even maybe you can reuse existing models, existing domain models that already exist, and adapt these to your needs. So the basic first step in creating a domain model is to find conceptual classes. Basically, you can check for nouns in requirements or when talking to experts. When they talk about something, note it down, and this is a candidate for a conceptual class. There are also these category lists in the course literature that can be an inspiration. If you already have an existing domain model, you can of course reuse the conceptual classes from that model. And finally, use brainstorming to get as many conceptual classes out there. And you prepare for brainstorming by reading the requirements, reading the books, or looking at the information available about this problem that you are supposed to model. And then you just try to find as many concepts as you can, and you don't debate if it's really a concept or not during the brainstorming. And at a later step you then filter and remove the conceptual classes, but during the actual brainstorming you just add as much as possible. So after you have found a lot of conceptual classes, then it's time to maybe remove some of them. During brainstorming in a group setting, it's natural that people tend to think about the same conceptual classes and maybe naming them a little bit differently, but remove all of the obvious duplicates and put them together in one conceptual class. One can also think a little bit about each of the concepts. Is it a class or is it an attribute? Typically, attributes are more primitive data types. So for example, in the student course administration example, the first name was not a concept, it was an attribute. And basically that was because it's a fairly primitive string type attribute rather than a concept in its own. Also, these concepts that tend to become attributes are really very generic. So a first name, you wouldn't really be able to place it in a specific domain. It's very generic to many domains. So think about if things are a conceptual class or if it's actually an attribute in a conceptual class. So if it's not obviously a primitive data type or something like that, I would suggest that you keep it as a conceptual class, because chances are that things are more complicated than you think. Another thing that comes up are report classes. That is something that is a visualization or a report over some information that already exists in the class. We could imagine that when brainstorming for the student administration system, somewhere in the requirement it was mentioned that a teacher would like to be able to have a list over the students attending the course. It could be tempting then to add the student list as a concept. However, this is probably just a report over information. So it's the report over the students that attend a specific course. It is not a class of its own, really. So you can debate if you should include the report classes or not. If you have a really small model, then I would suggest actually keeping report classes at least in the initial steps. If the model becomes too large, and well, then report classes are definitely candidates to be removed, or at least note that this is just a report over some information that already exists. So taking a look again at our student administration system, we can imagine that the requirements state that we should be able to know in what year a particular student attended the course. So we can then of course add an attribute here to the course, and it is a year. The year this course was actually given. And using that, we can, for example, tweak our object diagram, and let's say it's the same course here, really, 1dv607 again, but they are different because they are in different years. 2020. So let's also add another attribute. Maybe we want to know how many credits you get for each of the courses. And this is basically a real number. And again, looking at the object diagram, we can add this attribute. Oops, slot credits 7.5, and it's the same for this one. Maybe we should rename it distance version. Let's have it as an anonymous object. And this one also. All right, so we now have two course objects, both representing the same course but in different years. So we can then know that the student number 1 attended both years, both 2021 and 2020, and student number 2 attended just the 2021, and student number 3 attended 2020. So in this way we can know when a student actually attended the course. But we can also see that information is duplicated here between these two objects, and that is maybe not a good thing. So we can imagine, for example, that we have a lot of information, then a lot of information would need to be duplicated. We can also imagine that we would like to be able to change information in only one place, and just be able to change in one object would be an advantage. So maybe there is this thing in our domain called a course description. So let's add that instead. And we have an association between the course and the course description, and we need to set the name here, and we remove the name, the role name, and we remove that role name, and we set 1 and 1. So basically we now have a course and a course description, and let's show the association name. You can probably put it like that also. I like that better. And here we should rather have, let's see if we can move. Yes, we could. So we realized that we could add this course description class to our model that then becomes a better representation of this domain. So the code and the credits for a course do not really change between the years. They are the same. At least that's how our model says it is. And we need to, of course, verify that with reality also. All right, that's description classes. I don't think you should overuse them, but in some cases they can be really helpful. And then, of course, we would have our instance. Let's have it as an anonymous. And it's a course description. And both are, of course, linked to the same course description object. .607. So the object diagram would look something like this in this particular case. And thinking about the multiplicities, we can also use our object diagrams to check if they are correct. So a course is described by one course description. It would not make sense that a course is described by several course descriptions. However, looking at the object diagram, we can see that one course description object actually can link to several courses. So we should update this multiplicity to many. And if you have a one-to-one multiplicity, I usually just hide these multiplicities. The next thing to think about are actors, and actors are basically the roles that users play in the system. So, for example, we have a teacher role in our student administrative system. So the teacher would like to be able to get a list of students for different courses. However, we did not add the teacher as a conceptual class in the model, because the teacher just is someone who can do some things right now. It's not something that we need to save information about. We can imagine that students also have a role in this student administrative system. They can also do some things in the system, but they are also an integral part of the information that we actually need to have in the system for the requirements to work. So in that case, the actor student is also a conceptual class in the domain model. This is something you really need to think about. Is the actor just someone who can do things? Then we do not specifically need to add it to the domain model. If we have a need to save some information regarding the actor in the system, for example, in our case, what courses a student has attended, because that's a fundamental part of the requirements, then we need to add the actor to the domain model. Lastly, but not leastly, we have different domains becoming mixed, and this can be a little bit tricky, because when you look at the requirements, you may find many conceptual classes and maybe they are in different domains. So requirements can come from a multitude of different sources. Maybe some of them are not really involved at all in the domain that you are trying to model. So if that is the case, you should probably separate these into different domain models. So don't try to mix concepts from different domains into the same model. The next step after finding a lot of conceptual classes and filtering them and purging them from duplicates, etc., is to find associations between the classes. An association is a named relation between two classes that is meaningful and important. Basically, the associations describe how the conceptual classes need to be connected so that we can fulfill their requirements. That is, in our example, we need to know that student has attended a number of courses so that we can present a list of students for a particular course. So there needs to be an association between the conceptual classes student and course in order for us to remember this. Other examples of associations can come from domain rules, laws, and standards. For example, using our knowledge of the course administration system, we can realize that maybe a course needs to have a responsible teacher and also an examiner. This can be the same person, but they can also be different persons. In this case, also some employee of the university becomes an important conceptual class if we have such a requirement. So associations are based on some things that need to be remembered, need to be available over time in our domain. You can also use a common association list presented in the book to try to find suitable associations in your domain. A similar approach to looking at nouns to find conceptual classes, you can scan for verbs in the requirements. However, I think that this can be a little bit problematic since you often just reflect what people do if you use the verbs. But that can at least be used with some care. Some things to think about when working with associations in domain models. Use good association names. So the association should in itself reflect some property that is important in the domain. So try to find good names for the associations. For example, we want to know that a student attends courses. So attends is maybe a good name in this particular domain. Try to avoid these mundane has, contains, or consists of association names. Sometimes they are what you can come up with, but try to find good association names that actually describes the relationships between the two classes. Add multiplicity when needed. I would say that the multiplicity often explains the association in quite a good way. So learn how to use multiplicities effectively. We have also a few special things called derived associations and association classes. Derived associations are things that you can actually find by using other associations, but sometimes it is good for readability to add the association even though that this information can really be found by using other entities or other associations. You just simply put a slash in front of the association name in that case. And this slash actually also goes for attributes. We can imagine that we have a sum of the credits that a student has achieved for his education. This is probably just a derived attribute, something that we can compute based on what courses the student has attended and passed. So adding it as an attribute into the student class is maybe a little bit redundant. On the other hand, it also shows the information clearly. So then we can add this slash in front of the attribute or association name to show that this is something that is derived. It's not an item of data or an association in its own right. Association classes are special types of classes that you add to the association itself. That is, for example, maybe we would like to add a grade and for our students when they attend a course. This is not something that we can do right now, but this is rather something that we can use an association class. So when a student and a course are linked using the association, we want to add extra information for this particular link, and then we can use an association class. Association has two cousins, or two specializations really, composition and aggregation. I would stay away from those when doing domain modeling. They just add complexity really, so stay away from composition and aggregation in the domain models. You can of course have multiple associations. That is an association between these same two, multiple associations between the same two conceptual classes. For example, if we add this teacher class, then each course has a responsible teacher and an examinator. So we have two associations between the same two conceptual classes, course and teacher. You can also have reflexive association. That is an association that is between two objects of the same type. That is, the association goes to the same class. So let's look at some examples of this. So let's start by adding the teacher concept, and let's say that we can have the course needs a responsible teacher. It has one and only one, and it has teacher on the other hand can of course be responsible for several courses. And let's remove those. And let's show the one, show hide labels. Well, I could probably just remove the end names there also if I wanted to. But let's show the association name. So we have a responsible, and we should also have an examiner for every. Oops, wrong. I don't know if that's the correct English word, but whatnot. Examinator, and it's the same multiplicity. A course must have one examinator and only one, and teacher can be the examinator for several courses. Let's see if we can move that to the side a little bit, and maybe let's oops. And names, those are really called role names. So all right, so now we can see that every course has one responsible teacher and one examiner. Let's guess that that's the English term for this. And a teacher can be the responsible for several courses and be the examiner for several courses also. So this is an example of multiple associations between the same classes. All right. So let's now say that we would like to actually add the grade for the student when a course has been attended. So in this case, we cannot really do that because we cannot put the grade in the course, because then every student would have the same grade, and we can of course not put the grade in the student, because then we would either need to add one grade attribute for every course, and that would just suck and be totally illogical, So then we use this association class instead. And it seems like we need to remove the old one and add this. Let's call it result. And let's hide the end names and set the multiplicities to many. And that one too many, and again. Let's call this one at tens. And let's add the attribute grade. Something like that maybe. So now we can have, I would actually have preferred to have the association name here also, but that does not seem to be available in this tool, and well, you have to live with that, I guess. So we can see that the student can attend a number of courses, and the course can still be attended by many students, and we can add this grade to each of the students when they are attending. So let's take a look at the object diagram, because that has changed a little bit now that we have refined the link between a student and a course. So the instance, the attends link here actually then becomes an object in its own right. And for some reason, it does not seem like you can select it from the list here, but searching for it, I found that it worked. And the link now goes from the student to the attends object, and from the attends object to the course. And here, of course, we can add the grade. Let's say pass. Thinking about grades also, they are probably more complicated than a single number or a single string or letter combination. I would suspect that a grade actually is a conceptual class in its own right, but let's keep it a little bit simple for now. So if you want to do an object diagram like this, then you should check the objects like this when you're using an association class. I couldn't really find an example for a reflexive association in this example, but basically the association would be something like this. Let's pretend that we have some kind of social media feature going on here. So we add so let's say that the student can have friends or study comrades or something like that. So a student can have many students as friends. And a student can, of course, be befriended by many other students. I don't really think that this friend concept fits into the domain of the course administrative system, but well, it's an example. And in the object diagram now we of course can link the students. So let's say that student 1 is linked to student 2 and to student 3. So student 1 and student 2 are friends, student 1 and student 3 are friends. Student 2 and student 3 are not friends. The last big thing in domain modeling are the attributes for the classes. And basically this is the information or data that is needed to support the requirements. So if we if we in our list of courses need to print the course code, then we need a course code attribute, or this data available in some form at least. So basically you can think about this in what is actually being input into the system and what is the output. In some way we need to have that data in our domain model. Often the attributes are primitive data types, and as I said before, you can sometimes debate if an attribute is actually a conceptual class in its own right. Adding every little piece of attribute in the domain model often creates a domain model that, well, the conceptual classes become quite large. So focus on things that are a little bit odd or strange or advanced, or give an explanatory power to the conceptual class so that you understand the class a little bit better by looking at the attributes, what it actually is. Of course, if you have good tools, then maybe you can hide attributes that are not needed right now and things like that. So tooling helps, of course. If you find that you have many attributes, you can document these at the side of the visual model, so to speak, to not clutter it up too much in a data dictionary or glossary or something like that. Something that can help also with attribute is the use of data type classes. We can imagine, for example, having an address conceptual class that contains information about street and city and things like that. Maybe many classes in our domain needs an address, and maybe you even have multiple addresses in for example, a person. Then it can be really hard to show visually the association between these conceptual classes and that all go to this address concept. Just becomes too many lines. Then you can use address as a data type class instead. Basically you use it as a primitive data type. Remember that this is actually an exception and should be used with care. So basically when you create your domain model, focus on the associations and use that and not data type classes. That is really an exception. And as explained before, we can have derived attribute, that is things that are actually being attributes that you can actually compute based on information that is already available in the model, but they can also be important or strange or advanced and give explanatory power to your model, and then you just add a slash in front of this attribute. For example, in our student administrative system, we could probably now compute the sum of all the credits for a specific student by looking at if he or she has a passing grade and looking at the course and the credits in the course. We can compute how many credits the student actually has achieved. But this could also be something that you want to show in your model, that it has a total earned credits or something like that in the student as a derived attribute. One thing that is commonly a problem in domain modeling is that you forget about history and time. Often you have things that you need to remember over time, but it can be tricky to actually find this out, as it's often assumed more or less by the domain experts. We can imagine that we have an e-commerce system where we have items that you can buy, and all of these items have a price. You could be tempted to just add price as an attribute for the item, but probably the item price will change over time because you have discounts on certain days. Maybe the price gets raised over time or even gets lowered over time. And this is maybe something you intuitively do not really understand or the domain expert makes it a little bit too simple when they try to explain things to you. So always try to investigate, is this something, this attribute, something that we actually need to remember over time? And to do that, you can use timestamp classes to remember that, all right, this thing is something, this price, for example, is something that is valid for an item between these two dates that is present in this price class. And then you have this history, so to speak, of prices for every item that you can look up. So you can know the price of this item for a particular point in time. Association classes are also commonly used to add this timestamped for an association. Finally, the domain model can also include general concepts. So maybe you have this concept of something that is a more general version, and you have a couple of classes that are more specific versions of this general concept. We can imagine that student and teacher has some parts that are actually duplicated between them. Both will probably have a first name. Maybe we should create a person concept instead and use generalization, specialization to show that both the student and the teachers are persons. When you try to model things with generalization, you should apply the 100% rule. So all the information in the more general concept and all the relations, associations in the more general concept should also apply to the special concepts. So we cannot add something in the more general conceptual class that does not apply to one of the child classes. You should also be able to say that the more special concepts are a type of the more general concept. So a teacher is a person and a student is a person. Both the teacher and the student have first names. So in this case, maybe the 100% rule and the is a rule applies. The specializations that we add should add something to the model. So it could be that they add an attribute. It could be that they add associations. For example, a student attends courses. That's not something that the teacher does. Another way to think about it is that in the system or in the requirements, there is some different handling of these more special concepts. So you need to know that right now I'm handling this type of concept, and there are some special rules or special requirements that tend to this type of concept. All right, I hope you learned some more things about domain modeling. Bye bye.